Denmark has started extracting oil and gas in the North Sea in 1972. For the last 50 years, this industry has contributed immensely to the national economy and welfare. But fossil fuels are a major contributor to climate change. With the decision of the Danish government in 2020 to stop oil and gas production, we also started looking at decommissioning the infrastructure, and we believe that the infrastructure can be reused for technologies such as CO2 storage. DTU Offshore is a Danish national R&D centre for offshore technologies. We started in 2014, we're based at the Danish Technical University, and our initial goals were to increase oil and gas recovery in the Danish part of the North Sea. In 2019, we began the transition to more sustainable operation. We understand subsurface, we understand produced water management, we understand broader topics within the offshore environment, and we understand the infrastructure. We know that the technologies we work with are critical for the energy transition. We're going to go out there and understand and design the energy transition, design these solutions so they can minimize the harmful impact.
Okay. We're working on the CO2 injection for the CO2 storage project.
This is the set of experiments that you were working on, the impurities, right?
When considering CO2 storage scenarios, we do a lot of work to de-risk the situation. We have combined the classical petroleum engineering experiment of core flooding with advanced analytical chemistry within the same lab, so that we can take samples directly from the injection experiment in the core flooding setup and do chemical analysis. We need to understand the reaction of the chalk to these impurities in the CO2.
So we're actually seeing for the first time now that we can actually see different mixtures of chemicals here. They show up in the produced water, and this is what we want to measure, right? So we know what is actually being expelled to the ocean. Produced water is the water that comes along with the oil as it's produced. In carbon storage, in some cases you will lift out water from depleted reservoirs where you want to store CO2, and you will lift out this water, and that has to be cleaned. Presently, we are very good at actually removing oil droplets, chemicals, but we want to achieve much better results. We have these facilities, and we create both fundamental understanding and engineering solutions. We're also looking at other parts of the energy transition, energy islands. There will be wind turbines loaded with all kinds of fluids and chemicals, that it should be sustainable by design. This is what we can do with the knowledge we have.
Oh, hello, Jonas.
Hey, Lena.
What are you working on?
I'm trying to test a new sensor we have developed. We have increased the number of deposition cycles on the methane sensor to see if we can improve the sensitivity and the stability towards seawater. So the goal of our research is to develop sensor systems that are used for environmental monitoring, primarily for carbon storage sites as well as abandonment sites. So we don't want any methane coming out of the systems. We don't want any of the stored carbon dioxide coming out of the system, because that kind of defeats the purpose. As of now, we're in the process of building a prototype of a methane sensor. At the stage we're at now, we're basically setting everything up into a single-use device. We are planning to test this sensor under the most realistic conditions that is possible without going out to the North Sea. If the test is successful, this sensor system will be deployed on underwater vehicles to survey abandoned well sites and carbon storage sites in the future.
We need a bit more information from the operator. We need the model, for instance, then we can validate it against their own models, their own results. And I'm part of an interface between the researchers on one side and the industry, which also sponsor what we're doing. We set up a dedicated department to take care of the maturation, also of the cooperation with the industry. And me and my colleagues, we have a lot of experience because we came from the industry originally. The process of maturing the research into implementation is quite interesting. We evaluate and rank new projects. We mature things to a prototype level. That prototype is then used by our clients. We are here to help solve your problems together.
We know that the technologies we work with are critical for the energy transition, but in this journey we cannot travel alone. We have a unique collaboration model. We work closely with the industry that provides us with real industry challenges. At the same time, we are a partnership of 5 leading Danish research institutions: Technical University of Denmark, Copenhagen University, Aalborg University, Aarhus University, and Geological Survey of Denmark. So today we talk to our existing partners and we address new partners to tap into the different challenges in the industry and also to look for future funding. Technology and innovation are essential for the energy transition. Get in touch with us to hear more and get involved in our journey.